Now with this respect, let's do some problem, very simple one to start with. Problem says if a computer A runs program in 10 seconds and computer B runs the same program in 15 seconds, how much faster A than B? So we are trying to compare performance of A with respect to performance of B. So we take the ratio of performance A to performance B, which is execution time in B by execution time in A, which is from the problem, it is 15 seconds by 10 seconds, so it is 1.5. So machine A is 1.5 times faster than machine B. Now, there are a couple of components in this execution time, right? So the wall clock, what we were calling so far as a response time or the relapse time, that is when you request a computing system to execute your program, and when it finishes it, the time between that is your response time or elapsed time. It is a wall clock time. Now wall clock time has one component called CPU time, and that's what we are interested in to measure performance of our processor. So you can probably ask, what is the other component than the CPU time? So CPU time is the time a program is executed in central processing unit or the processor. So it is really a program utilizing the processor, right? So what is the other time? Other time is that it can incur, first of all, well, your program is executing, accessing the memories, for example, or accessing IO devices. So those are all the IO time. Basically, it's not the CPU time, but it's the input output time. That's another component. Okay. For multiprocess environment, there are wait time as well, like time to time operating system sends one process to sleep mode so that it can schedule other jobs to the processor. So that wait time is also, or sleep time is also part of your wall clock time. So that is your wall clock time, is your complete experience of the execution. Like you send a program, that program sometimes can go into sleep state or wait state, perform IOs, and rest of the part is utilizing your processor, where it is being really executed within the processor. Means processor is fetching your instruction one by one and execute them, and so on and so forth. Now system performance refers to the wall clock time. So when we talk, okay, what is my system performance, is that's the wall clock time, whereas CPU performance refers to the user CPU time. Now we haven't talked about these two terms. Like CPU time has two parts again in it. One is the user CPU time and another is the system CPU time. So what is the distinction between them? If you think of your software program, whatever you are writing, it uses a bunch of system libraries, like math library, for example, is a system library. IO library is another example of system library. So your program time to time call those functions in the system libraries, like some math function, some math method, some IO methods. So when you call those system function or system method, control goes into the system system functions, right? Then they become, or they are counted in terms of system CPU time. It means your program total CPU time, that how much part has been used for your program, like your code, or and how much time it's spent for within the system library functions. Okay, so these are the two major things. So we are more interested in the user CPU time because we don't have really control over the system CPU time, because that library function is basically predefined and we cannot do anything about that. So what all we can do to improve performance of our software is to tune our code, right? So that's why when we talk about our CPU performance, so we mean that the user CPU time, like that our code, like users program code, spent how much time in CPU. Okay, so that's the definition of the CPU performance.